So we can apply the formula for the double slit, which is lambda equals ax divided by d. So for a, we can rearrange to have lambda d divided by x, and don't forget to convert, because units of length are not all in SI unit, so you should convert. X is distance across 5 bright fringes, and even from the drawing here you can notice that we should divide by 4, because here is one segment of this distance, here is the second, the third, and the fourth. So this 4 will go to be multiplied in the numerator and on calculator. As it is a stationary wave, B and Q cannot have different frequencies, cannot have same amplitude, cannot have different periods, certainly if they don't have different frequencies. So always in phase. Remember that only when there is a separation by nodes there is a change in phase, but in the same peak or trough in the standing or stationary wave, we have same phase or in phase. So for n, it is equal to d sine theta divided by lambda. D is 1 over this number, and we should convert per millimeter to per meter. So under the 400 we will multiply by 10 to minus 3 times sine theta, as we are looking for the highest order. Okay, we will make this theta by 90 and sine theta by 1 times 1 over the wavelength. Again, don't forget to convert on your calculator, and as this will go for the numerator, you can find the answer as 4. Certainly power is a squared over r, or I squared times r, or I times v. Any possible charge on a particle should be a multiple of 1.6 times 10 to minus 19. So each choice should be divided by this number, and the answer will be that gives a multiple, not a fraction. Okay, you can find the answer here as C. For the lamp, we know that as increasing voltage, I increases, but instead of linear increase, like an ohmic resistance, it is a non-ohmic, so the increase is a curve, so it's B, and certainly cannot be Q because Q has no decreasing gradient or no decreasing rate, but here we have a decreasing rate, okay, or a decreasing gradient, sorry, and this gradient represents 1 over R. Remember, V equals IR for ohmic, so R, which is equal V over I for ohmic resistor. It is a line, and R is the slope. For non-ohmic, it is the gradient, and as the gradient decreases, R decreases, but this if V on y-axis and I on x-axis, in case we make I on y-axis and V on x-axis, the slope is 1 over R, okay? And as this slope decreases, R increases, and this goes along with our knowledge that increasing current increases temperature and increases opposition to electrons flow, so increases resistance. With respect to diode, this graph is well known for no potential until some, no current until some value for the potential it goes up. So we have P and R. Okay, if we looked to this junction, we have 3 ampere current goes in, and we have also 2 ampere current goes in. Okay, so we should have here 3 ampere and 2 ampere enters this point, so out of this point should be 5 ampere, because Kirchhoff first states that current enter equals current leaving. So sum of current enters is 5, so current leaving should be 5. And if we apply Kirchhoff's second for this loop, okay, we can say that better is 9 minus 1, and minus because current is pushed in this direction, and this battery push in the other direction, so it is 9 minus 1 for batteries. This equals the potential difference across the component of the loop with the direction of the loop. We will take it as positive, so the current 5 ampere in resistor B, okay, will be taken positively, okay, because it follows the direction of the loop. And for resistor 2, the current is 3, and again it follows the direction of the loop, so it is 3 times 2, 6, the potential across the 2 ohm resistor. From this equation, you can find that this 8 minus 6 is 2 over 5 gives RB, which is 0.4. Okay, adding a resistor in parallel will decreases the R total, and such a decrease will cause the current in the circuit to increase, and when current in circuit increases, potential difference across the R small, which is IR small, will increase. Okay. It's a quite difficult ratio problem, but here it is. R1, which is the total resistance for the two parallel resistors X and Y, is Rx Ry over Rx plus Ry. Rx is rho L over by R squared, okay, times Ry, which is the same, gives all squared, okay. Can remove this and write by squared R to power 4 over the addition rho L over by R squared, okay, times 2. Can simplify this by removing these squares, and we can remove this also, and the remaining here will just by R squared, so it is rho L over by R squared over 2, which means times 2. R2 is the same, but in this case we have change for one of the wires radius to 2R, but same material, same length, so we can write rho L squared over pi squared R to power 4, but remember it is R squared times 2R squared. Okay, so it is R squared times 4R to power 2. Okay, so we have here 4, and this is divided by rho L over by here 1 over R squared, and here 1 over 4R squared. Can again take R squared as a common factor, remove it from here, and we have 1 plus 1 over 4, can also remove it and make 5 over 4. Can remove rho L with the squares by R squared and leave here by R squared. Don't forget the 4. This 4 will goes up in the denominator, so it will cancel this 4. Okay, and we have left with rho L over 5 by R squared. So if we divided R1 by R2, okay, we will have certainly L over pi R squared eliminated, and we will have a, sorry, this 2 is in the denominator, so it should be here. Again, R1 over R2 will simply be 1 over 2 over 1 over 5, which is 5 over 2. I1 equals I2 plus 4 and 5. This is correct because it enters this point, and what is leaving is I2 and I3, which is I4 and 5. I2 equals I1 minus I3. I2 is leaving, I1 is entering, and I3 is leaving. This is true. I2 equals I3 plus I4, which is I3 plus I4 plus I5. This is not correct. Okay, for the first sulfide emission, we have a decrease here by 4 and here by 2. For beta, mass number remains the same and atomic increases by 1. For alpha again, it decreases by 4 and this decreases by 2, so it is 90. Alpha for the third time gives us this. So as we have the overall charge here is positive 1 elementary charge, or positive 1.6 times 10 to minus 19. This means is that the atom lost 1 electron. So electrons decreases by 1, it is 39, and definitely all goes right. We have proton inside the nucleus the same, and neutrons is the difference between the two, the mass number and neutron proton number. Which particle is lepton? It is the positron.